My name is Chamuleau. I'm a cardiologist in Utrecht, and one of my major points of interest is ischemic heart disease and the fact that we really don't have treatment for those patients at present. My major drive for regenerative medicine in cardiology starts with the patient. So the patient is really in need. I see these patients every day, and that's the reason that I'm looking for new opportunities to help these patients. In particular, regenerative medicine is of my interest because it's fascinating to have a look at what's happening in the heart in terms of endogenous repair. 10 years ago, we were not aware that the heart was able to repair itself, and now we know it is. And the next step is that we try to enhance that. And that's my drive for research.
My name is Sluijter and I'm a professor of the Department of Cardiology. And in my research, we're focusing on how to make the stem cell work for the heart failure patient. That we're using two ways. One is we're using the stem cells to make cardiac tissue in a dish by using 3D bioprinting. And we're using the vesicles that are derived from our stem cells to help the patient and deliver these vesicles into the heart to help the heart perform better. So recent years we experienced that if we inject our cells into the damaged heart of the patient, is that these cells are flushed out immediately upon injection. And therefore we observed that we have to do something with these cells. And that's why we came up with the idea to use 3D bioprinting and to use small carriers that we co-inject together with the cells, and thereby help these cells to stay on the spot where we inject them, and that can do their job to help the myocardium that's damaged on that local area. When we injected the cells into the heart, we did observe that these cells had an effect, and thereby we experienced that these cells apparently are releasing factors in their environment, and these are small vesicles. They're called exosomes. And now we're having these exosomes here in our cultures that we start isolating, and that way we start treating our patients. At least that's the idea for the next years, that we are leading in this field, that we are expanding these isolation protocols, that we can use them for the patients, and thereby we don't inject the stem cells themselves, but we'll inject their secretions in the form of these small vesicles.
Our group is also putting a lot of interest and research facilities into developing new delivery strategies. And you have to think about new catheter development, but also the incorporation of 3D fusion of imaging modalities. So really advanced imaging modalities, looking at fibrosis using MRI or using deformation imaging with echocardiography to really guide the operator to the right spot in the heart. And if you can combine that together with novel techniques like biomaterials to enhance the material within the heart, I do believe that in the upcoming years we will be much better in doing the job of stem cell transplantation to the heart.